All right, this is section 2.4b, multiplying, dividing fractions. So this is coming after the decimal lesson where we're multiplying, dividing decimals. And I think you're going to find that multiplying and dividing with fractions is much easier than multiplying and dividing with decimals, and obviously much easier than adding or subtracting with the fractions that we had to do. So this is going to be much easier today. And here are your steps for multiplying fractions. First of all, you want to convert mixed numbers to improper fractions. This also includes whole numbers. And this step is not optional. We know that that was optional when we were adding or subtracting with fractions. You could leave them as mixed numbers. We cannot do that with when we're multiplying or dividing them. The second thing you want to do is you want to cancel. And canceling is reducing before you multiply. And that's going to save us work in two parts. Number one, if we cancel, the numbers are going to get smaller and they'll be easier to multiply. And number two, if we cancel, we won't have to reduce. So we can reduce while the numbers are still small. Step 3, multiply across the top and bottom, and then step 4, count the negatives. And this is important. We do not want to find a common denominator. Do not find a common denominator. That is something you only do when you add or subtract with fractions. So let's look at the first example here, 4/9 times 15/22. We do not need to find a common denominator. We're not adding here. We're multiplying, so we're going to cancel. And when you can cancel any top number with any bottom number. So we can cancel this 4 with this 22 and just pretend it was 4 over 22 for a second. You can see that 2 would go into both of those because they're even, which makes this a 2 and this an 11. So 2 11s. But we can also cancel the 9 and the 15. 3 goes into 9 3 times, and 3 goes into 15 5 times. And that looks like all we're going to be able to cancel. And that saved us work here in two ways. The numbers are much easier to multiply now. 2 times 5 is 10, and 3 times 11 is 33. And also, we do not have to reduce 10 over 33 because if you cancel as much as you can, you won't have to reduce. Example B. First thing you would do is you would turn this whole number, this -9, into a -9 over 1, so it's a fraction. And then it may even help you to rewrite that as 5 over 18 times 9 over 1. Now notice I didn't write any negatives because I know that if I have two negatives, it's going to make a positive, so I don't need to worry about that. And then we can cancel the 9 and the 18. 9 goes into itself once, 9 goes into 18 twice. Now, if you were thinking 3 also goes into 9 and 3 also goes into 18, but you'd have to reduce it down again. So try to find that GCF, that greatest common factor that goes into both numbers, so to save yourself some time. Then we multiply across the top to get 5. 5 times 1, 2 times 1 is 2, and then our answer is positive 5 over 2. Example C, this is the ultimate example of why canceling is going to save you time and effort. If you look at 27 times 11, I don't know what that is off the top of my head. I definitely don't know what 55 times 36 is, so I would have to do a bunch of side work for this problem. But I can cancel. First of all, our answer is going to be negative because we have one negative sign. And then you may have noticed that 11 and 55 have a common factor of 11. So you can take 11 into 11 one time, and 11 goes into 55 5 times. And then 27 and 36 have a common factor of 9 again. 9 goes into 27 3 times. 9 goes into 36 4 times. So now when you look at these numbers, you don't have to go off to the side to multiply. 3 times 1 is 3, and 5 times 4 is 20. So our answer is -3/20. Canceling saves you a lot of time, and we know we don't have to reduce because we canceled as far down as we could. In the next example, we want to write both these numbers as improper fractions. So 3 times 3 is 9, plus 1 is 10/3, times 10 times 2 is 20, plus 7 is 27/10. One of the numbers is negative, so my answer is going to be negative. And then we try to cancel again. These 10s have a common factor of 10, so they'll cancel each other out. 10 goes into 10 once. And then 3 and 27 have a common factor. 3 goes into itself once, and 3 goes into 27 9 times. So we get 1 times 9 is 9, 1 times 1 is 1. The only time that you'll have to reduce after you cancel is if you get a 1 on the bottom. Instead of writing 9 over 1, we just want to write that as 9, and remember our answer was negative. So -9. So that brings us to dividing fractions. Now remember, when you divide decimals, you have to do long division. We don't have to do long division here. This is going to be pretty easy, actually. The first thing you want to do, again, like last time when you multiplied, is you want to convert all of your mixed numbers or whole numbers into improper fractions. So you must have improper fractions. The second thing you want to do, and you may remember this, is to keep, change, and flip. We're going to keep the first number the same. We're going to change the division to multiplication, and we're going to take the reciprocal of that second number, which means we flip it upside down if it's a fraction. Obviously, we need to have them as fractions, as improper fractions will work as well. Now, you must do the change and you must do the flip before you cancel. Okay, you can only cancel when you multiply. So we're going to keep, change, flip so that we're multiplying, and then we can cancel. Then we're going to multiply across the top and bottom, and then we're going to count the negatives. All right, so in the first example, we're going to keep the first fraction the same. We're going to change the division sign to a multiplication symbol, and we're going to flip the second fraction upside down, take the reciprocal of it, so it's 8/3. Now, again, I know one of the numbers is negative, so my answer is going to be negative, so I can just put that negative right down there. Now that we've flipped it and changed it to a multiplication problem, we can cancel. And the 4 and the 8 will cancel. 4 goes into itself once, it goes into 8 twice. 1 times 2 is 2, and 1 times 3 is 3. So we still have to cancel, or we still have to reduce fractions, but canceling means we can do it while the numbers are still small, which is much easier to do. Example B. -3/4 divided by -2. We're going to change this -2 to -2/1, and then we're going to keep the first fraction. We're going to change to multiply, and we're going to flip 2/1, so it's 1/2. Notice that both of the numbers are negative, so my answer is going to be positive. And then we look to see if anything cancels, and the 3 and the 4 can't cancel. The 3 and the 2 cannot cancel. And actually, nothing's going to cancel here. So if nothing cancels, that means nothing will reduce, and we can just go ahead and multiply across the top to get 3, and multiply across the top to get bottom, and we said it was going to be positive 3/8. So positive 3/8 for example B. For example C, we can turn -2 4/5 into an improper fraction. 2 times 5 is 10, plus 4 is 14/5, divided by, and this is going to be 7/1. And then we can keep the first fraction the same. We can change it to multiply, and we can flip that 7/1 upside down, so it's 1/7. You'll notice that both numbers are negative, so this is going to make a positive answer. And then we can cancel the 7 and the 14 to make the 14 to 2 now. 2 times 1 is 2. 5 times 1 is 5. So we get positive 2/5 for our answer. In example D, we've already got one of the numbers as an improper fraction, so 16/5. We're going to still divide here because we have to change 3 and 1/5 to 16/5. And you may notice, actually, now one of the numbers is negative, so your answer is going to be negative. But you may notice that you're dividing 16/5 by itself. And when you divide a number by itself, your answer is just going to be 1. But just in case, you can see that if we keep and change and flip, the 5s are going to cancel out, and the 16s are going to cancel out, and you get 1/1, which is 1. And because one of the numbers is negative, our answer is -1. All right, in this next example, we're raising -1 2/3 to the third power. So that's the same as -5/3, by the way. So I've got -5/3 times -5/3 times -5/3. And I know that 3 negatives makes a negative still, so my answer is going to be negative. Nothing cancels. The 5s can't cancel with themselves because it has to be a top number with a bottom number if you're going to cancel. So if nothing cancels, nothing's going to reduce. 5 times 5 is 25. 25 times 5 is 125. 3 times 3 is 9, and 9 times 3 is 27. So we get -125/27. For example B, I can see that I've got 2 negatives, so my answer is going to be a positive. And we can write this as 1/7 times 4/5 times, and we have to turn 7 into 7/1. And the interesting thing about this is that the 7s can cancel because it was any top number with any bottom number, even if the 7's over here and the other one's over here. There's still a top and a bottom. And because they are changing to ones, we have 1 times 4 times 1, which is 4, and 1 times 5 times 1, which is 5. So positive, because of the two negatives, 4/5. And for the last one here, negative 2/3 times, and we're going to change this to, see, 7 times 8 is 56, plus 7 more is 63/8, times 3 halves. And we got one negative number here, so our answer is going to be negative. We don't need to flip anything because we're multiplying, we're not dividing in this problem, so none of the fractions have to be flipped upside down. And the 2's here on the outside can cancel with themselves. The 3's on the outside here can cancel with themselves, and that gives us negative 63/8 is our final answer, and we don't need to turn that into a mixed number. We can leave it as negative 63/8.